Hi students, exercise 5.1 question number 13. If n is a positive integer using binomial theorem, using binomial theorem, show that 9 power n plus 1 minus 8n minus 9 is always divisible by 64. Similarly, these problems already proved in principle of mathematical induction. Here in the same problem using binomial theorem, using binomial theorem, proof. To prove the result is 9 power n plus 1 minus 8n minus 9 is divisible by 64. Divisible by 64. Now let 9 power n plus 1. 9 power n plus 1. Here 9 power n plus 1 means 9 product into n plus 1 time, isn't it? Yes. Here using binomial theorem means expressions having sum of two terms, isn't it? Expressions having sum of two terms. Therefore 9 we can split to 1 plus 8. 1 plus 8 whole power n plus 1. This is in binomial expressions. 1 plus 8 whole power n plus 1 expanding, that is n plus 1 into c naught 1 power n plus 1 minus 0, that is n plus 1 8 power 0. Plus then the second term n plus 1. N plus 1 c1 1 power n plus 1 minus 1, plus 1 minus 1 are cancelled, then the remaining is n 8 power 1 plus n plus 1 c2 1 power n plus 1 minus 2 is n minus 1 8 power 2 plus n plus 1 c3 1 power n minus 2 8 power 3 plus on so on. Then the last term n plus 1 c n plus 1 n plus 1 c n plus 1. 1 power n plus 1 minus n plus 1 is 0, that is 1 power 0. The remaining 8 power n plus 1. 8 power n plus 1. Here simplify, that is n plus 1 c naught is value is 1. 1 power anything is 1. 8 power 0 is 1. Therefore the first term is 1. Then the next term n plus 1 c1. N plus 1 c1 means n plus 1. Then 1 power n is 1. 8 power 1 is 8. 8 power 1 is 8 plus then the second term n plus 1 c2. N plus 1 c2 1 power n minus 1 is 1. 8 square. 8 square. Then the next term n plus 1 c3. N plus 1 c3 8 power 3 plus n plus 1 c4 8 power 4 plus on so on, plus then the last term is n plus 1 c n plus 1 is 1. 1 power 0 is 1. 8 power n plus 1. Then the remaining is 8 power n plus 1. 8 power n plus 1. Then the left hand side is 9 power n plus 1, which is equal to, here first term is 1 plus then the second term is the scalar 8 multiply into the factor n plus 1. That is 8 into n 8n plus 8 into 1 8. Plus then the remaining term have, each term have 8 square 8 square 8 square 8 square. Take outside 8 square, then the remaining terms. That is we take 8 square to out of the remaining terms. Okay, out of the remaining terms, that is here n plus 1 c2. Okay, n plus 1 c2 plus here n plus 1 c3 into 8 power 3 means 8 squared is take outside, then the remaining is 8 power 1. Okay, 8 power 1 plus n plus 1 c4 into 8 power 2 plus and so on. Then the last term 8 power n plus 1. Okay, we take 8 square in each term, that is 8 power, then goes to numerator, that is 8 power minus 2 is in the last term remaining 8 power n minus 1. Okay, 8 power n minus 1. Here 1 plus 8. Okay, 1 plus 8 is 9. Okay, 8n, and these terms are goes to left hand side. Okay, goes to left hand side. Then the result is 9 power n plus 1. 8n goes to left hand side like as minus 8n. Here 8 plus 1 9 goes to left hand side, then the sign like as negative, that is minus 9, which is equal to here 8 squared is 64. Okay, 8 squared is 64. Then the remaining term is n plus 1 c2, n plus 1 c2 in plus n plus 1 c3 into 8 power 1 plus n plus 1 c4 8 power 2 plus and so on. Then the last term is 8 power n minus 1. Okay, 8 power n minus 1. Here 9 power n plus 1 minus 8n minus 9, which is equal to 64 times of some constant. Okay, 64 times of some constant, which is divisible by 64, isn't it? Yes. Therefore 9 power n plus 1 minus 8n minus 9 is divisible by 64. Hence proved. Okay. Exercise 5.1, question number 10. If n is an odd positive integer. Okay, odd positive integer. Prove that the coefficients of the middle term in the expansion of x plus y the whole power n are equal. Okay, proof. Here given the binomial is given x plus y whole power n is the binomial. Okay, the n is like as odd positive integer. Okay, odd positive integer. Okay, odd positive integer means like as, it means contains two middle terms. Okay, two middle terms, that is t n minus 1 by 2 plus 1, then the another one is t n plus 1 divided by 2 plus 1. Okay, like odd positive integer means containing two middle terms. This is one middle term, this is the another one middle terms. Okay, here prove that the coefficients of the middle terms in the expansion of x plus y whole power n are equal. It means the coefficient of this term and coefficient of these terms both are equal. Okay, that is the proof. To prove coefficient of t n minus 1 by 2 plus 1, which is equal to coefficient of t n plus 1 divided by 2 plus 1. Okay, we know that r plus 1th term, that is t r plus 1, which is equal to NCR. Okay, here r like as r. Okay, r like as r. NCR x power n minus r y power r. Okay, y power r. This is the r plus 1th term. It means x plus y whole power n contains exactly n plus 1 terms, isn't it? Yes. Here t rth term means t r plus 1, which is equal to NCR x power n minus r y power r. Okay, here two terms This is the first term, this is the another one terms. Here t n minus 1 by 2 plus 1. Okay, here substitute r equal to n minus 1 by 2. Here that is n c r is n minus 1 divided by 2. Okay, x power n minus r. n minus r is n minus 1 divided by 2. y power r is n minus 1 divided by 2. Okay, t n plus, next find t n plus 1 by 2 plus 1. Okay, which is equal to n c r is n plus 1 by 2 x power n minus r. n minus r is n plus 1 divided by 2 y power r, that is n plus 1 divided by 2. Here to prove coefficient of nc n minus 1 by 2 which is equal to nc n plus 1 by 2. Okay, to prove coefficient of nc n minus 1 by 2 which is equal to nc n plus 1 divided by 2. Okay, here we take LHS. Okay, we take LHS. Now we take LHS, that is nc n minus 1 by 2. Okay, nc n minus 1 by 2. Here using one property, that is property is ncr which is equal to nc n minus r. Okay, nc n minus r. Using this property into here, that is ncr which is equal to nc n minus r. n is n minus r is n minus 1 divided by 2. Okay, n minus 1 divided by 2. Here take LCM, that is using cross multiplication, that is n c here 2n product minus 1 into here into these brackets, that is minus n minus of minus plus 1 divided by 2. Okay, here 2n minus n is n plus 1 divided by 2, that is n c n plus 1 divided by 2. Okay, now we take LHS, we get RHS. Okay, therefore coefficient of middle terms, okay, n like as odd positive integer means containing two middle terms, the coefficients are equal. Okay, coefficients are equal, hence proved. Exercise 5.1, question number 13. In the binomial expansion of a plus b the whole power n, if the coefficients of 4th and 13th term are equal. Okay, here given binomial expression is a plus b the whole power n. Okay, then the condition is coefficient of 4th term and 13th term are equal. Okay, we equate to coefficient of 4th term and the 13th term to find the value of n. Okay, to find the value of n. Solution: given binomial expressions is a plus b the whole power n. This is a binomial expansion. Okay, binomial expressions. Here then the condition is coefficient of 4th term which is equal to coefficient of 13th term. Okay, 13th term. This is the condition. Okay, to find the value of n. To find value of n. Okay, here we know that the r plus 1th term, we know that is t r plus 1 which is equal to n c r a power n minus r b power r. Okay, b power r. Here substitute r equal to 1 means, okay, here substitute r equal to 1 means we get the second term of the expansion. Okay, we get the second term of the expansion. Suppose substitute r equal to 0 means, r equal to 0 means 0 plus 1 is 1. That is the coefficient of the first term. Okay, coefficient of the first term, or first term of the expansion. Okay, first term of the expansion a plus b the whole power n. Suppose r equal to 2 means 2 plus 1 is 3. Okay, t3 means third term of the expansion. Okay, third term of the expansion a plus b the whole power n. Similarly to the same process, we get fourth term of coefficient. Okay, we get fourth term of coefficient means substitute r equal to 3. Okay, substitute r equal to 3. Fourth term means substitute r equal to 3, we get the fourth term. Okay, here t3 plus 1 which is equal to t fourth term. Okay, fourth term. Here r is 3, n is n, c r is 3, a power n minus 3 b power 3. Okay, this is equation number 1. Now find 13th term. Okay, 13th term. Substitute r equal to 12, we get the 13th term. Okay, here t 12 plus 1 which is equal to t 13th term, n c r is 12, a power n minus 12, b power 12. This is equation number 2. Here given coefficient of fourth term which is equal to coefficient of 13th term. Okay, here coefficient means this is the coefficient. Okay, nc3. This is fourth term coefficient. This is 13th term coefficient. Given both are equal means nc3. Okay, nc3 which is equal to nc12. Okay, which is equal to nc12. Here to find the value of n. Okay, to find the value of n. nc3 means n factorial divided by n minus 3 factorial into 3 factorial. Isn't it? Yes. Here nc12 means n factorial divided by n minus 12 factorial into 12 factorial. Okay, this is using combination formula. Okay, then the calculation is 2 length. Okay, here using one more property, that is, we know that if ncx, okay, ncx which is equal to ncy, okay, which is equal to ncy. Here ncx equal to ncy means x plus y. Okay, x plus y which is equal to n. Okay, which is equal to n. Using this property into here, we get the value of n. That is, here x equal to 3, y equal to 12. Okay, x plus y which is equal to, here x equal to 3, y equal to 12. 3 plus 12 which is equal to 15. That is the n. Okay, n equal to x plus y. Therefore n equal to 15. Okay. Exercise 5.1, question number 15. In the binomial expansion of 1 plus x the whole power n, the coefficient of the 5th, 6th and 7th terms, okay, are in AP. Okay, here given binomial expressions is 1 plus x the whole power n. Okay. Now then the condition is coefficient of 5th term, 6th term and 7th term are in AP. Okay, are in AP. Then find the value of n. Okay, find the value of n. Solution: given binomial expression is 1 plus x the whole power n. Then the condition is coefficient of 5th, 6th and 7th term are in AP. Okay, are in AP. AP means arithmetic progression. Okay, here for example, now we take A, B, C. Okay, now we take A, B, C. Okay, in question are in AP. Okay, are in AP. Then the condition is here sum of first and third term. Okay, sum of first and third term A plus C. Okay, divided by 2. Okay, divided by 2 which is equal to middle term. Okay, which is equal to middle term B equal to A plus C divided by 2, or sum of first term and third term A plus C which is equal to 2 times of middle term. Okay, which is equal to 2 times of middle term. Satisfy these conditions, therefore the given series A comma B comma C. Okay, this is A comma B comma C, then the sequence is R in AP. R in AP. Okay, this is the condition for AP. Okay, using this condition into here, that is fifth term is coefficient of fifth term. Fifth term means substitute R equal to 4, we get the fifth term of the expansion 1 plus x the whole power n. Okay, here we know that the general term T R plus 1, 4 plus 1 which is equal to NC, this is the R, isn't it? NC4 1 power n minus 4 x power 4. Okay, x power 4. This is equation number 1. Okay, next sixth term. Sixth term means substitute R equal to 5. Substitute R equal to 5. We get the sixth term in the expansion of 1 plus x the whole power n. Okay, here T 5 plus 1 which is equal to NCR. NCR means 5. 1 power n minus 5 x power 5. This is equation number 2. Okay, next find the seventh term. Okay, seventh term is substitute R equal to 6, we get the seventh term of the expansion 1 plus x the whole power n. Okay, substitute R equal to 6 plus 1 which is equal to n c 6 1 power n minus 6 x power 6. This is equation number 3. Okay, now given the coefficient of 5th, 6th and 7th term are in AP. Coefficient means this is the coefficient of 5th term, this is the coefficient of 6th term, this is the coefficient of 7th term. Okay, given n c4 comma n c5 comma n c6 are in AP. Okay, are in AP, arithmetic progression. Okay, it means 2 times of middle term. This is first term. Okay, this is first term This is middle term, that is second term. Okay, that is second term. This is third term. Okay, third one. Here product of product of middle terms 2 times, that is 2 times of NC5, which is equal to sum of the first and third term. Okay, that is NC4 plus NC6. Okay, plus NC6 to find the value of n. Okay, here 2 times of NC5 using combination formula, that is 2 times of n factorial divided by n minus 5 factorial into 5 factorial. Okay, which is equal to NC4 means n factorial divided by n minus 4 factorial into 4 factorial plus NC6 means n factorial divided by n minus 6 factorial into 6 factorial. Here then the numerator 2 factorial, sorry, n factorial, n factorial, n factorial are cancelled. Then the denominator changed to n minus 5 factorial is changed to n minus 4 factorial, that is 2 divided by n minus 5 is n minus 5 into n minus 4 factorial. Okay, then the 5 factorial changed to 5 into 4 factorial. Okay, 5 into 4 factorial. Right hand side 1 divided by n minus 4 factorial into 4 factorial. Okay, into 4 factorial. Here plus 1 divided by n minus 6 factorial is n minus 6 into n minus 5 into n minus 4 factorial. 6 factorial change to 6 into 5 into 4 factorial. Here then the denominator have n minus 4 factorial, n minus 4 factorial, n minus 4 factorial are cancelled, and 4 factorial, 4 factorial, 4 factorial are cancelled. Then the remaining result is 2 divided by 5 times of n minus 5. Okay, which is equal to 1 divided here 1 plus here 1 divided by n minus 6 n minus 5. Okay, then the remaining is 6 into 5. Okay, 6 into 5 is 30. Okay, 6 into 5 is 30. Here taking LCM, that is using cross multiplication. Here using cross multiplication, that is 2 divided by 5 into n minus 5, which is equal to using cross multiplication, that is 30 into n minus 6 into n minus 5 plus 1 divided by 30 into n minus 6 into n minus 5. Okay, here 5, 30 are cancelled. Okay, that is 6 times. N minus 5, n minus 5 are cancelled. Using cross multiplication, that is 2 into 6. Okay, 2 into 6 into n minus 6. 2 into 6 into n minus 6, which is equal to here 30 into n minus 6 into n minus 5, that is n into n square, here minus 6n minus 5n, that is minus 11n, minus plus 6 into 5 30 plus 1. Okay, here 2 into 6 12, 12 into n 12n, 2 into 6 12, 12 minus 6 minus 72, which is equal to 30n square minus 30 into 11. Okay, 30 into 11, 330n plus 3 3s are 900 plus 1. Okay, rearranging quadratic equation of n, that is 30n square. Here goes to right hand side, that is minus 12n. Okay, minus 330 minus 12 is minus 342n. Okay, minus 72 goes to right hand side like as opposite sign, that is positive sign. Okay, here 900 plus 1 901 plus 72 is 973. Okay, plus 973 which is equal to 0, which is equal to 0. Okay, this is multiple of 3, this is also multiple of 3, this is here simplify we get, that is 30, simplify, then the factor is here simplify, then the factor is n minus 14 into n minus 7 which is equal to 0. Okay, please check to these steps. Okay, here then the factor equal to 0, then the factor equal to 0, that is n minus 14 equal to 0, we get n equal to 14. Now n minus 7 equal to 0, we get n equal to 7. Therefore the value of n is 7 comma 14. Okay, exercise 5.1 question number 16. Prove that c0 square plus c1 square plus c2 square plus and so on plus cn square which is equal to 2n factorial divided by n factorial the whole square. Okay, proof. Now we take 1 plus x the whole power n. Okay, 1 plus x the whole power n. Using this expansion, binomial expansion, 1 plus x the whole power n is n c naught 1 power n minus 0, that is n x power 0 plus n c1 1 power n minus 1 x power 1. Okay, plus n c2 1 power n minus 2 x power 2 plus n c3 1 power n minus 3 x power 3 plus and so on plus n c n 1 power n minus n, that is 0 x power n. Okay, simplify, that is nc naught is 1. Okay, nc naught is 1, 1 power n is 1, x power 0 is 1, that is nc naught plus here nc1 x power 1 plus nc2 x power 2 plus nc3 x power 3 plus and so on plus nc naught x power ncn x power n. Okay, x power n. This is equation number 1. Now consider another one binomial expansion, that is now consider x plus 1 the whole power n. Okay, x plus 1 the whole power n. In the first one we take 1 plus x the whole power n. Now we take x plus 1 the whole power n. Okay, using binomial expansion, that is nc naught x power n minus 0 1 power 0. Okay, plus nc1 x power n minus 1 power 1 plus nc2 x power n minus 2 1 power 2 plus nc3 x power n minus 3 1 power 3 plus and so on, then the last term ncn x power n minus n 1 power n. simplify into these, we get nc naught x power n, okay, plus nc1 x power n minus 1 plus nc2 x power n minus 2 plus and so on. Then the last term is ncn x power n minus n is 0, okay, x power 0. This is equation number 2, okay. This is equation number 1, this is equation number 2. Here from equation 1 and 2, okay, from equation 1 and 2, sum of two equations, okay, sum of two equations, that is 1 plus x whole power n, x plus 1 whole power n. Base are same means add the powers, that is n plus n is 2n, isn't it? 2n. From equation 1 and 2, collect the coefficient of x power n only, okay, collect coefficient of x power n, okay, x power n on both sides, okay, on both sides. Then the left hand side, 1 plus x whole power n, 1 plus x plus 1 whole power n, that is 2n, isn't it? 2n coefficient means 2n cn, okay, because collecting the coefficient of x power n, that is 2n cn, okay. This is equal to here nc naught product into ncn x power 0 product to x power n, okay. Here x power 0 product to x power n, nc1 x power 1 product to x power n minus 1, okay, x power n minus 1, that is nc naught whole square plus nc1 whole square plus nc2 whole square plus nc3 whole square plus and so on ncn whole square, okay. Then the left hand side is using combination formula, that is 2n factorial divided by 2n minus n factorial into n factorial, which is equal to, in the right hand side, nc naught square plus nc1 square plus nc2 square plus and so on. Then the last term ncn square, okay. Here 2n minus n is n factorial, n factorial is n factorial the whole square, that is 2n factorial divided by n factorial the whole square, which is equal to, here we know that ncr represent to ncr, okay, which is equal to ncr, which is equal to cr, okay, which is equal to cr. Both are all of these represent to combination, okay, combination. Similarly to the same process, using this format into here, that is nc naught the whole square, which can be written as c naught square plus c1 square plus c2 square plus and so on plus cn square, okay. Therefore hence proved, okay, hence proved. Exercise 5.1, question number 14. If the binomial coefficients of three consecutive terms, okay, in the expansion of a plus x the whole power n are in the ratio 1:7:42, then find n. Here given binomial expansion is a plus x the whole power n, that is the binomial expression a plus x the whole power n, okay. Here binomial coefficients of three consecutive terms. Consecutive means alternative terms, isn't it? Consecutive means alternative terms, okay, are in the expansion of a plus x the whole power n. These consecutive terms are in the ratio 1:7:42. Then find the value of n. Solution: given binomial expression is a plus x the whole power n. Okay. Now 3 consecutive term is r minus 1 comma r plus 1 are 3 consecutive terms. Okay, 3 consecutive terms. Okay, are in the ratio 1:7:42. Here r minus 1/3 term means r minus 1/3 term. Okay, minus 1/3 term is here t r minus 1 plus 1, which is equal to r minus 1 plus 1 is tr. Okay, tr, which is equal to here n c r minus 1 expands in a plus x, that is a power n minus r minus 1 minus of minus plus 1 and x power r minus 1, x power r minus 1. Okay, this is equation number 1. Then the next one is rth term. Okay, rth term means that is t r plus 1. Okay, that is n c r a power n minus r x power r. This is equation number 2. Okay, r plus 1th term is r plus 1th term means t r plus 1 plus 1, which is equal to t r plus 2. Okay, which is equal to n c r is r plus 1 a power n minus r minus 1 x power r plus 1. This is equation number 3. Okay, given the coefficient of consecutive terms, 3 consecutive terms are in the ratio 1:7:42. Okay, given coefficient of 3 consecutive terms, 3 consecutive terms are in the ratio 1:7:42. Okay, now equating the ratio 1:7:42 coefficient of 3 consecutive terms. This is the first one, that is n c r minus 1 is to, and the second one is n c r is to n c r plus 1. Okay, n c r plus 1, which is equal to 1:7:42. Okay, 1:7:42. Here n c r minus 1 divided by n c r, which is equal to 1 divided by 7. Okay, 1 divided by 7. This is equation number 4. Then the another one is NCR divided by NCR divided by NCR plus 1, which is equal to 7 divided by 42. Okay, this is equation number 5. Okay, now we take equation 4, simplify, that is, now we take equation 4, that is n c r minus 1 divided by n c r, which is equal to 1 divided by 7. Okay, using cross multiplication or simplify, otherwise using cross multiplication, that is n factorial divided by n minus r minus of minus plus 1 factorial into r minus 1 factorial divided by NCR is n factorial divided by n minus r factorial into r factorial. Okay, which is equal to 1 divided by 7. Here, numerator have fraction, denominator have fraction. Using multiplication, then the denominator like as reciprocal, isn't it? That is n factorial are cancel. Then the remaining is n minus r factorial into r factorial divided by n minus r plus 1 factorial into r minus 1 factorial, which is equal to 1 divided by 7. Here n minus r plus 1 factorial change to n minus r factorial into r factorial is r into r minus 1 factorial divided by denominator n minus r plus 1 into n minus r plus 1 minus 1 is plus 1 minus 1 are cancelled, then the remaining is n minus r factorial into r minus 1 factorial, which is equal to 1 divided by 7. Here r minus 1 factorial are cancelled, n minus r factorial are cancelled, then the remaining is using cross multiplication, that is 7r, which is equal to here 7r, which is equal to n 1 times of n minus r plus 1. Okay, that is 7r goes to right hand side like as negative sign. Okay, then the constant goes to left hand side like as negative sign, that is n minus 8r. Okay, n minus 8r, which is equal to minus 1. This is equation number 6. Okay, similarly now we take equation number 5. Okay, now we take equation number 5, that is NCR means n factorial divided by n minus r factorial into r factorial. Okay, product, then the denominator using combination formula, that is n minus r minus 1 factorial into r plus 1 factorial divided by n factorial, which is equal to 7 divided by 42. Okay, here n factorial are cancelled, then the result is n minus r factorial, which can be written as similarly r plus 1 factorial can be written as n minus r minus 1 factorial into r plus 1 into r factorial divided by here n minus r into n minus r minus 1 factorial into r factorial, which is equal to 1 divided by 6. Okay, 1 divided by 6. Here r factorial are cancelled, n minus r minus 1 factorial, n minus r minus 1 factorial are cancelled. Using cross multiplication, that is 6 into r plus 1, which is equal to 1 times of n minus r. Okay, 6 product into here, that is 6r plus 6, isn't it? Yes, goes to right hand side, that is n minus r, 6r go to right hand side, that is minus 6r, which is equal to 6. Okay, which is equal to 6. Simplify, that is n minus 7r, which is equal to 6. This is equation number 7. Okay, which is equation number 7. Now using equation 6 and 7, from equation 6 and 7, 6 and 7, n minus 8r, which is equal to minus 1. This is equation number 6. Okay, equation 7 is n minus 7r, which is equal to 6. This is equation number 7. Okay, equation 6 minus 7 means change to the sign. Okay, change to sign, that is n minus n r cancel, minus 8r plus 7r, that is minus r, which is equal to minus 1 minus 6 is minus 7. Both side minus are cancelled, then the result of r is 7. Okay, in our problem to find the value of n, therefore the value of r equal to 7. Substitute in these equations, we get the required solution. Okay, that is r equal to 7. Substitute in equation number 6. Okay, that is n minus 8 into r is 7, which is equal to minus 1. Here 8 sevens are 56, goes to right hand side, that is plus 56, minus 1 plus 56. Therefore the value of n is 55. Okay, then the value of n is 55.